We will now review another type of descent and approach mode. We assume that you have programmed the FMGS for descent and approach. The aircraft is in cruise. The expected approach is VOR DME 23 left. The FMGS has computed a descent profile, assuming that the aircraft will descend initially with idle thrust and econ descent speed, and then will follow the descent profile in order to reach 1,000 feet HEL at V approach. The symbol for this type of descent is illustrated by the symbol T/D on the MCDU and the arrow symbol on the ND. The aircraft has just overflown the top of descent. The FMA displays the message Decelerate. The suggestion is to select the lower speed since the aircraft will be above the descent profile. The aircraft vertical position versus the descent path is indicated by the vertical deviation VDEV symbol along the altitude scale. You can see that the aircraft is approximately 300 feet above path. ATC clears you to descend to 11,000 feet. Since you have LNAV engaged, you decide to use a VNAV descent. Push the altitude knob to initiate the descent. By pushing the altitude selector, you have engaged VNAV. Descent, DES, appears on the FMA. Thrust is reduced to thrust idle mode. This mode will attempt to maintain a descent path with zero vertical deviation. The magenta circle shows deviation from the computed descent path. In a VNAV descent, a symbol appears on the speed scale showing the target speed. A set of magenta brackets appears above and below the target speed symbol, ultimately providing a plus and minus 20 knot range. This provides flexibility for the system to maintain idle thrust by varying the speed when external conditions are not as expected, such as different winds than forecast or aircraft kept high by ATC. In this example, note that the aircraft is above the path. The system will compensate by pitching nose down until the speed is at the upper margin of the speed range. If the aircraft is really high above the descent path, even the increased speed may not be enough to compensate, especially if there is an altitude constraint ahead. In this case, the ND intercept symbol is too close to the constraint waypoint. In these cases, the FMA displays a more drag message. It is a suggestion to use speed brakes to increase the rate of descent. Extend the speed brakes. Once the aircraft is back on the descent path, VDEV close to zero, the more drag message disappears. The speed brakes may now be retracted. Suppose you keep the speed brakes extended. Since the aircraft is in VNAV, the system will attempt to keep the aircraft on the descent path. However, in this case, the speed will drop below the target speed. To keep the speed from becoming too low, the autothrottle will revert from idle to speed to maintain the target speed, even though the speed brakes are still extended. This is obviously not efficient. Should this scenario happen, speed brakes extended, thrust above idle, the speed brake memo turns amber and flashes on the engine warning display. Retract the speed brakes. ATC gives you a heading of 255. On the ND, the solid green line now indicates the track line, and the flight plan is shown in dotted green. At the same time, the descent mode automatically reverts to the present vertical speed of minus 1,000 feet per minute. The cardinal rule is LNAV must be engaged before VNAV. Thus, when you engage the heading mode, LNAV disengages, and VNAV automatically reverts to the current vertical speed. You are level at 2,000 feet. The approach phase has been activated. The weather is VFR, and you are going to do a visual approach backed up by the data for a VOR approach to runway 23. You have chosen to fly the approach using track flight path angle. The FMAs show altitude and track, indicating that the aircraft will now maintain 2,000 feet on a selected track of 255. When you intercept the approach course, you select the VOR approach track of 227 degrees. Even if the wind varies during final approach, you will fly a constant track during the approach. On the approach chart, you have determined that the final approach path is -3 degrees and starts at 4.4 DME, labeled FAF on the approach chart. As you cross the FAF, you engage the FPA mode by selecting -3.0 and by pulling the FPA selector on the flight control unit. Pull the FPA. The FMA displays FPA -3.0 degrees, indicating that the autopilot will descend on a -3 degree descent path. After crossing the FAF, select the proper go-around altitude and cross-check the approach using raw data information, VOR bearing, altitude versus DME. Even though in visual conditions at MDA, you still have not received a clearance to land, so you have to level off. Push the vertical speed flight path angle knob to level off. The FMA indicates FPA 0.0 degrees, showing that the aircraft is level. At the missed approach point, you still have no clearance to land, so you go around. To engage go around, the thrust levers must be pushed into the toga detent. When the go-around mode is engaged, the FMAs indicate manual toga. Throttles are now manually controlled, since toga is beyond the auto throttle engagement range. SRS, the vertical mode similar to takeoff. SRS will maintain V approach or aircraft speed, whichever is higher. Go-around track, the lateral mode. The autopilot maintains the track memorized at the time of go-around. Auto thrust. The FMA is now in blue, meaning the auto throttles are no longer engaged, but are armed for re-engagement. Depending on the clearance, you may either fly the published miss by pushing the heading knob, nav mode, the missed approach procedure, or if tower issues a heading, pull the heading knob. In this case, you are to fly the published miss. The missed approach procedure now becomes the active flight plan. Push in the heading knob. The nav mode engages and the aircraft begins to fly the missed approach. The tower has the communication problem solved, so you are now re-cleared to land on the same runway. Airport and runway in sight, cleared to land.